Hello everyone, welcome to this channel. This question has been taken from Olympiad Pathfinder, Chapter 12, multiple choice question number 28. Two identical point charges are moving in free space. When they are 60 centimeter apart, their velocity vectors are equal in modulus. These two are equal in modulus and make angles of 45 degree from the line joining them as shown in the figure. If at this instant their kinetic energy is equal to, in this condition, kinetic energy is equal to their potential energy, what will be the distance of closest approach between them? Four options are given. We have to select the correct option. Let us solve this. Given is two identical point charge particles moving in free space. Okay. We have assumed that Q was the charge on it and its mass is M. So when the two point charge particles are Ri is equal to 60 centimeter apart, I stands for initial condition, R subscript I, and making an angle of 45 degree from the line joining the two charges. At this instant, the total kinetic energy is equal to the potential energy, and we have to find the distance of closest approach. What is happening? The electrostatic force on the respective particles are always acting parallel to the x-axis. They are identical charge, so it will be in this direction. On this particle it will be in this direction, and there is no force in the y-axis, along the y-axis. So component of velocity in the y direction will never change throughout the motion. Due to the force acting in the x direction, the x component of the velocity Vx will keep on decreasing as the electrostatic force is acting opposite to it. Vx is in this direction, force is acting in this direction, so it will keep on decelerating in the x direction. Therefore, Vx will diminish to zero gradually at one point, and then due to electrostatic force acting on it, the direction of it will reverse and keep on increasing. So the closest distance between the particles will be when the x component of the velocity Vx becomes 0. Okay, from this figure and the questions, the total kinetic energy of the particles is equal to potential energy of the particles when the gap is 60 centimeter. So total kinetic energy is, one particle is having this much kinetic energy, half m v subscript I square. So there are two particles, so it will be multiplied by 2. So total kinetic energy will be this much. And potential energy of the system, you know, by formula is kq square by r subscript I. So from here we will be getting Vi square is equal to kq square by mri. That is, we should say this as equation 1. Now at any gap between the particle when it was r centimeter, we will write the Newton's law equation from the Newton's law of motion. So summation of force in the x direction for particle 1 and dvx by dt, we will multiply with dr and divide by dr. So the equation will become this way. Dr by dt will be the Vx, you know, and force summation of all the forces in the x direction on particle 1 is Fe. So that magnitude is Fe. So we can write that by Coulomb's law, kq square by r square. So finally you will get this equation. Vx dvx is equal to kq square by r square m into dr. When we integrate both sides for the velocity, initial velocity, that is Vi, to 0, and correspondingly the r will be Ri, that is 60 centimeter, to R minimum, because the velocity in component in the x direction has become zeros. So at that time, the gap between the two particles will be minimum. Upon solving the above equation and putting the value, we will be getting R minimum is equal to 40 centimeter. So answer C will be the correct answer. Hopefully you understood the concept. If any issue in understanding, please do write in the comment box. I will come back on that. Thank you.